Usually when we look at a map of a city or like a sprawling shopping mall or even a giant theme park, there's always that big comforting red star
Yeah.
right there on the board.
Right, the one that boldly declares, "You are here."
Yes, exactly. It instantly centers you.
Yep.
It makes you feel like the entire landscape with all its chaotic paths and twisting landmarks is just, well, organized around your exact physical position.
Oh, absolutely. It gives this profound sense of control. I mean, wherever you need to go, everything radiates outward from where you currently stand.
Yeah.
We inherently like feeling like we are the undisputed center of the story. It gives our existence a very clear, undeniable structure.
But then you step into the historical world of early astronomy, and suddenly someone comes along with a giant eraser and just completely wipes that red star off the map.
Totally gone.
Right. We are talking about a historical landscape that was entirely disrupted. I mean, the map of human existence was redrawn, and it left humanity feeling completely unmoored.
It was the absolute definition of a paradigm shift. Humanity went from being the undeniable VIPs of the universe, sitting securely in the absolute center of everything, to realizing we are just living on another piece of rock, spinning in the dark.
Okay, let's unpack this.
Mhm.
Because the scene of this realization is almost cinematic, really.
Oh, for sure.
We have an era defined by a very specific worldview, and we have this deep, calm night with shining stars overhead. We've all experienced that, right? A perfectly clear, dark night where you just look up and feel a sense of awe.
Right, it's universal.
But the excerpt we are diving into today frames this not just as a pretty romantic scene. It is the literal backdrop for a search for ultimate truth.
Yeah, that's a crucial distinction.
A man named Galileo wasn't just casually stargazing to pass the time. He was actively searching for answers in that deep night, aiming to completely reorder the heavens.
Exactly. Because looking at the sky to appreciate its beauty is one thing, but looking at the sky to interrogate reality itself is something entirely different. And to really understand the weight of that interrogation, we have to look at the societal landscape of Galileo's Italy.
Growing up in that environment, he was fundamentally different from his peers. While the people all around him were focused entirely on everyday life, you know, commerce, social dynamics, just getting by day to day, he was obsessed with finding answers up above,
He was definitely the outlier.
big time.
Yeah.
I try to imagine what it actually feels like to harbor a serious, persistent doubt about something that literally every single person on Earth believes is an absolute, undeniable fact.
It's hard to wrap your head around today. You were talking about a period where the geocentric model, the belief that everything revolved around Earth, wasn't just a casual scientific theory.
Right.
It was the bedrock of their entire shared reality. It dictated their physics, their philosophy, and honestly, their understanding of humanity's importance.
Yeah, because if Earth is the center of everything, then humanity is the focal point of creation.
Precisely. So to question that isn't just questioning a map, it's questioning the purpose of life itself.
Right. But Galileo believed something fundamentally different. His core philosophy, which drove this entire paradigm shift, was simply this: truth is not just in books, it is hidden in the universe.
What's fascinating here is the massive shift in authority that single sentence represents. It really cannot be overstated. Think about what books meant at that time.
They were everything.
Right. They represented traditional, received wisdom. They represented what the ancient authorities like Aristotle or Ptolemy told you was true.
Wow, yeah.
Knowledge wasn't something you discovered, it was something you inherited from the past.
So relying on books meant you were constantly looking backward for answers rather than, looking at what was actually happening right in front of you.
Exactly. By stating that truth is hidden in the universe, Galileo is moving away from taking someone else's word for it.
Right.
He is shifting towards seeking empirical, observable evidence. He is demanding that nature speak for itself, rather than trying to force nature to agree with the dusty manuscript. It is the birth of a radically different way of processing reality.
To really grasp what Galileo was up against, we need to understand the mechanics of the worldview he was doubting.
Oh, the math.
Yeah, that Earth-centric model wasn't just a simple idea. It was a highly complex mathematical nightmare that people accepted simply because authority demanded it, like a heavy anchor holding human thought in place.
Right, and he was trying to cut the rope. Because the planets don't actually orbit the Earth, their movements in the sky appear very strange if you assume we are standing still.
Oh, right, retrograde motion.
Exactly. Sometimes planets appear to stop, move backward, and then move forward again. To make this fit the Earth-centric model, Ancient astronomers had to invent these incredibly complex mathematical loopholes called epicycles.
Basically, they argued that planets were moving in little circles while simultaneously moving in a bigger circle around the Earth. I had to think of it like a spinning teacup ride at an amusement park.
That is a perfect analogy. And when the observations still didn't perfectly match the math, they had to keep adding epicycles upon epicycles, gears within gears. It became this crumbling, overly complicated mathematical structure, yet everyone accepted it because the books said Earth had to be the center.
Right.
Galileo's refusal to simply accept this chaotic mathematical patchwork was his first major break from his peers. He looked at the complexity and doubted it was the truth.
But, having doubts is merely the first step. You can stand around doubting the status quo all day long. Actually proving those doubts, dismantling that massive system of gears within gears, requires a completely new way of seeing.
Yes, it requires a tool.
And that brings us directly to his instrument of change. He builds a powerful telescope. But here's the crucial distinction in the source text. He didn't just look at the sky with his eyes anymore. He observed it with science.
And the profound difference between looking and observing with science is really the pivot point of modern astronomy.
Wait, really? Just that phrase?
Yeah, because looking is a passive experience. You open your eyes, light hits your retina, and you acknowledge what is in front of you. You might see a blurry light and think, oh, that's pretty.
So what does this all mean for the telescope itself? Did the telescope instantly change his mind? Or was it the strict discipline of how he used it? I mean, a tool is just a piece of glass and metal.
That's the key. A telescope in the hands of someone who just wants to see a slightly larger, blurry star is essentially just a toy.
Right.
Observing with science is an active, aggressive methodology. It requires intent, it requires meticulous measurement, and it requires critical analysis. Galileo wasn't just pointing a tube at the sky to see what was there. He was pointing it at the sky to test his specific doubts.
He applied a strict, rigorous discipline to his vision. And from what I understand, the early telescopes weren't exactly user-friendly either. They were essentially repurposed spyglasses, originally used by merchants to spot ships on the horizon.
Oh, they were terrible by modern standards. They had incredibly narrow fields of view and severe distortion.
Like looking through a funhouse mirror.
Kind of. Looking through one was like trying to understand a massive painting by peering through a tiny, blurry straw. You couldn't just sweep it across the sky and instantly understand the cosmos.
Ah.
You had to focus intensely on one tiny area, measure what you saw, record it, and compare it over time. The telescope didn't do the work. Galileo's scientific methodology did.
Armed with both this scientific method and his new technology, Galileo points his lens at a specific target. He focuses on Jupiter, and what he sees initially seems entirely unremarkable.
Right.
Near the massive planet, he spots 4 small, shining dots.
And his very first reaction was to assume they were just background stars.
Which is a completely logical hypothesis. I mean, you point a tube at the night sky, you see shiny dots, you categorize them as stars. What else would they be?
Exactly. And this is where we see the scientific process in its purest form. Science isn't about never being wrong or never making assumptions. It is about establishing a framework where your assumptions can be tested and, if necessary, discarded. Galileo made a perfectly reasonable hypothesis based on his initial observation. But because he was observing with science, he didn't stop there. He returned the next night.
And the next night, something fundamental had changed. Those 4 dots had moved.
And they hadn't just moved randomly either. They had shifted their positions relative to Jupiter. Some were closer, some were further away, and their overall alignment had changed.
So this wasn't some sudden lightning bolt eureka moment where he dropped his telescope and instantly understood the mechanics of the solar system.
Not at all.
The reality of the scientific process is much more suspenseful and meticulous. Night after night, he kept observing. He was taking detailed notes, measuring the distances of these dots from Jupiter.
He essentially created a grid in his mind, using the diameter of his telescope's field of view to measure exactly how far these dots were straying from the planet.
That is so clever.
Yeah, and he realized that sometimes a dot would completely disappear, only to reappear on the other side of Jupiter a few nights later.
He was tracking the patterns to overcome his own initial incorrect assumption that they were static stars. Here's where it gets really interesting for me.
Oh, yeah.
It's like looking out your window at night, and way off in the distance, you see some cars parked on a street near a large building. You assume they are just parked cars.
Makes sense.
But the next night, you look out, and those same cars are in different spots. And the next night, they've moved again. Eventually, by tracking them mathematically, you have this mind-bending realization those cars aren't parked on a street at all. They are doing continuous laps around that specific building.
That's a great way to picture it because when you realize they are doing continuous laps, the entire geometry of what you are observing changes.
Right.
You go from seeing background objects that you assume are fixed to the sky to realizing they are active, dynamic participants in an entirely separate system.
A system that operates completely independently of Earth.
And that realization is the true breakthrough. Galileo deduced the unavoidable truth. These were not stars, they were moons orbiting Jupiter.
Wow.
We know them today as Io, Europa, Ganymede, and Callisto.
4 little dots. But recognizing the orbital pattern of those 4 dots wasn't just a neat piece of astronomical trivia. It was a philosophical earthquake.
Huge.
It directly threatened the absolute status quo of humanity, providing undeniable proof that not everything revolves around Earth.
If we connect this to the bigger picture, to understand why this shattered centuries of belief, we really have to look at the core physical arguments of the time.
Right.
One of the main arguments against a moving Earth was our own moon. Philosophers argued that if the Earth was actually hurtling through space around the sun, it would leave its moon behind.
Ah, I see.
The physics of the time dictated that a moving object couldn't carry another orbiting object with it.
But then Galileo points to Jupiter.
Exactly. He points to Jupiter and says, look, Jupiter is clearly moving through the sky, and yet it is carrying these 4 moons along with it.
That is amazing.
It mechanically demolished the argument. If Jupiter could move and keep its moons, then Earth could move and keep its moon. Furthermore, if there are objects orbiting Jupiter, then Earth is no longer the sole center of motion in the universe.
It proved there are centers of gravity, centers of action that have absolutely nothing to do with us. It decenters humanity in a way that is incredibly jarring.
Yes, very unsettling for them.
Galileo laid out this undeniable, mathematically tracked, physically observable evidence. And yet, many people outright refused to accept it.
They absolutely refused. There are historical accounts of prominent scholars at the time literally refusing to look through Galileo's telescope.
See, that is the part that fascinates me the most. I have to play devil's advocate here. Why do human beings hold on to old beliefs so tightly?
It's a great question.
Why would highly educated people, scholars who dedicate their entire lives to studying the heavens, refuse to simply lean forward, look through a glass tube, and see the moons with their own eyes?
Because to look through that tube meant risking the destruction of their entire intellectual foundation. We discussed how deeply the Earth-centric model was tied to human identity and philosophy.
Right.
If the heavens are perfect and unchanging, as Aristotle claimed, then finding new moons that change position every night means Aristotle was wrong. And if Aristotle was wrong about the heavens, what else was he wrong about?
It's a terrifying domino effect. I guess we still see that today with information overload. When a belief is tied to your identity, your community, and your understanding of how the entire universe functions, letting go of that belief feels like letting go of reality itself.
Exactly. Accepting Galileo's truth meant accepting that the foundational books were flawed, the authorities were fallible, and the comforting map with the red "You Are Here" star in the center was completely fabricated.
Yeah, that makes sense.
It's easier to refuse to look through the lens than to face the overwhelming cognitive dissonance of realizing everything you know is wrong.
Which makes Galileo's actions even more remarkable. He didn't cave to the immense pressure of his peers. Despite the sheer refusal of the establishment to accept his findings, he stood with the truth.
He really did.
He trusted the rigorous empirical observation he conducted night after night over the comforting, widely accepted illusions of his time.
He trusted the truth hidden in the universe over the truth written in the books. And by doing so, he laid the very foundation of modern astronomy.
Yeah.
He earned the title Father of Modern Science, not just because he found 4 moons, but because he championed the methodology required to find them.
He cemented the idea that the universe is vast, and we are just a small part of it. It's a deeply humbling lesson. When you finally accept that you aren't the center of the universe, you are forced to acknowledge how massive and complex the cosmos actually is.
And by stepping off the center stage, humanity was finally able to see the true scale of the theater. Galileo's story is a testament to the power of human curiosity and the sheer courage it takes to follow the evidence, no matter where it leads or how uncomfortable it makes the people around you.
Right. It's about courage as much as science.
Exactly. It proves that reality is always waiting to be discovered, as long as we are willing to observe it with science rather than just looking at it through the lens of our preconceived assumptions.
One man, one telescope, and a relentless search for truth. That's all it took to completely change the world. For everyone listening, I want you to consider how incredibly empowering that realization
It's
is.
very empowering.
We tend to talk about historical paradigm shifts as these massive, unstoppable societal tidal waves, but they don't start that way. They start with one person simply deciding to observe the world critically,
Yeah.
realizing that the sheer act of asking questions, creating a methodology, and seeking tangible evidence can shatter centuries of rusted, complex dogma is, well, it's thrilling.
It demands that we remain active participants in our own understanding of the world. Galileo didn't wait for the universe to explain itself to him. He built a tool, established a method, and demanded answers.
So as you go about the rest of your day, I want to leave you with a lingering thought to mull over. We've explored how Galileo found a completely world-changing truth just by pointing a new tool at the calm night sky and challenging a belief that everyone thought was absolute.
Right.
What absolute truths in our own modern everyday lives might be completely overturned if we just dared to look at them through a different kind of lens today. Think about that map of your own life and the assumptions that guide it. Maybe it's time to stop staring at the red star that says you are here and